Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial video, I'll go through these combined science 5129 chemistry contents for these group 7 properties in continuation of the periodic table chemistry that we talked about previously. So here we're going to describe the group 7 halogens. So these are the special name given for group 7 element, which of course exists as diatomic non-metal. So diatomic means that they exist as two atoms. So diatomic means two atoms bonded together covalently. So two atoms covalently, so that means the two atoms share electrons and they are bonded to each other, covalently bonded to each other. Or you can say two atoms, two of the same non-metal group 7 elements forming covalent bond to each other, giving you the group 7 diatomic molecule. Down the group also known as descending group 7. So group 7, VII, as shown in the periodic table, you're going to get increasing density. So we know that density equal to mass over volume. So that is from your physics component or your lower secondary science, how heavy you are and how much space you occupy. So your density increases, and you also have decreasing reactivity. This is opposite to group 1 chemistry. So you know, in group 1, previously we talked about group 1 metals becoming more and more reactive down group 1, but this is opposite. This is opposite to group 1 chemistry. So here the group 7 halogen become less and less reactive down group 7. So here it becoming higher density. So I can comment about this if I just write that again. So that is higher density. And then the second feature is going down the group, I also become less reactive because this is group 7. So group 7 become less reactive down the group. We're also going to be able to state the appearance. Appearance meaning how it looks like. How it is or how it looks like. Oops. How it looks like. And this is that RTP. RTP refers to room temperature and pressure. So room temperature in science, which include biology, chemistry, and physics. So room temperature refer to 25 degrees Celsius and the pressure is 1 atmosphere. The unit is abbreviated as 1 atm, pressure. But the 25 degrees Celsius is a very important thing, which they will ask you on the states of matter, whether it's solid, liquid, or gas at 25 degrees Celsius. Chlorine is a yellow-green gas. Bromine exists as a reddish-brown liquid. So the green gas, the yellow-green gas is Cl2. The red-brown liquid is Br2. And of course, the gray-black solid is going to be I2. So looking at these, you can kind of like see the trend. Gas, liquid, and solid at 25 degrees Celsius room temperature. So that means it gets more and more difficult to melt and also boil going down to group 7 halogen. We can see that chlorine and bromine are toxic but not iodine. That is because we actually use iodine in hospitals and clinics. When you get cuts on your hands or on your feet or anywhere, you go to the hospital to get stitches. Before they stitch you up with needles and stuff, they will put some brown color solution. Brown color solution, that is iodine solution. When you dissolve the gray black solid iodine into water, then you get aqueous iodine, which you use as an antiseptic to kill germs and bacteria. Antiseptic on your wound before they stitch you up in the clinic or hospital. Now there's one final test. This is to test and identify chlorine gas. So I will append a experimental tutorial video on this to show you what is the result of using a damp litmus paper in order to test for chlorine gas, which exists as Cl2 there. We also have this describe and explain. So this is the biggest thing in group 7 chemistry. This is to do with the displacement reaction of halogens and how we place these halogens in their reactivity. Now that next bit is an aqueous solution. Aqueous from year 9 chemistry content, it means dissolve in water. So we had the yellow-green gas, which is the element, and now you get Cl2 aqueous. This is what you actually add to your drinking water, and this will disinfect your swimming pool. This will disinfect your drinking water. It will kill microorganisms and stuff. It's the last step in the purification of water. After you filter off the insoluble solid, you add the carbon to remove bad taste and bad smell, and then you disinfect drinking water with CO2 to make it safe for drinking, as it kills germs and bacteria. And then aqueous bromine. So aqueous bromine, Br2 aqueous, is not a reddish brown liquid. Liquid is pure element. You dissolve in water, you're going to get aqueous. Aqueous means dissolve in water. You're going to get orange solution. So aqueous is also known as solution there. Iodine, as I mentioned, this is the one where they stained your wound at a hospital, and then they will put some brown solution on your wound because this is antiseptic. If you don't believe me, you can go and buy iodine solution. It will be brown solution. We also have these reactions of halide ions. First of all, it's called ions. Second of all, it's called halide ions. We are referring to chloride, which is Cl- versus the bromide. So we are now talking about the IDE. Okay, IDE, and now we're talking about versus iodide I-. All of these has the IDE because all of these has the -1 charge of the ions, because we're talking about group 7, so 7th outer shell electrons, and therefore they will all gain 1 electrons to complete the outer shell. This is the test. This is part of the test for test for the halide ions. Very, very important in practical studies, as well as the new syllabus, which involve paper 3 alternative to practical for the combined science syllabus 5129, and also in the IGCSE combined science syllabus as well. And last but not least, we have these properties of other elements. Of course, you can extend the idea to fluorine, as well as astatine. So these are not in the syllabus, but then they can ask you to predict the properties of fluorine and astatine, because they already studied in the syllabus like that. Even though our case study is just chlorine, bromine, and iodine, therefore chloride, bromine, and iodide, we could also ask you something on fluorine and astatine. Moving on to the actual contents. So group 7 elements, special names, you call it halogens. These are group 7 elements. Halide ions, as I mentioned, the chloride, the one with the IDE, okay, the one with the IDE, halide ions, chloride, bromide, iodide. So I did spell it before, so I don't want to spell it again. Chloride, bromide, iodide. These are the ions. These are the halogens, chlorine, bromine, iodine. So these are just descriptions of how it looks like as an element. So this is Cl2 gas. It's a pale yellow-green gas. You need to be able to describe the color as well as the states of matter at 25 degrees Celsius. So this is a red-brown liquid at room temperature and pressure. This is gray-black solid at room temperature and pressure, 25 degrees Celsius. Aqueous means dissolve in water. So you dissolve the pale yellow-green gas in water, you get Cl2 aqueous. It appears colorless. This is what you add to swimming pool as well as drinking water to kill germs and bacteria. This is an orange solution. All of these are solutions because all of these are aqueous. You dissolve it in water. And this is a brown solution which you use as an antiseptic agent, which I did mention here. So for your wounds, it is not toxic. If it is toxic, we would not apply it on our body wounds. Wounds is when you have injuries. You want to prevent it from being infested with bacteria and stuff. You spray it or you just stain it with this brown color solution called iodine solution, because iodine is a solid. Dissolve it in water, you get iodine solution, which is brown. It is not toxic. We can apply it on our wounds, on our skin. However, chlorine and bromine is toxic. Chlorine and bromine is toxic. This is the safety hazard associated with chlorine as an element, chlorine gas, as well as bromine liquid there. In terms of the properties, so the color gets darker. There's the first one. The color gets darker, going from yellow to this pale green gas to red color, red-brown liquid to a black solid. And then we also think about the density increasing. That was the one stated in the syllabus. And then one thing which is not stated in the syllabus is to do with the melting and boiling point. Because when you think about the melting and boiling point, these two are gas. Then the next one is a liquid, and then the next one is a solid. So it becomes more and more difficult to melt. It becomes more and more difficult to boil. Okay, therefore the melting and boiling point increase going down to group 7. This is the test for anions that I will show you again in the next topic called qualitative analysis. So this is your test for your halide ions. And the halide ions are all in aqueous solution. So that means they are colorless solution because all of this is not the halogen, not halogen. So they are all colorless. The halogens are colored. So is the precipitate here. The PPT here refers to precipitate. If I just spell it out, you actually have learned it in precipitation reaction as part of acid, bases, and salt topic to prepare something which is insoluble. So it is insoluble, insoluble salt. Now, all of them, they have the same idea. You must acidify with dilute nitric acid. Dilute nitric acid is HNO3 acid. So this is nitric acid, dilute nitric acid. You acidify with dilute nitric acid. That is your first point. And then after that, you have to add aqueous silver nitrate. Aqueous silver nitrate is a colorless solution, and it's an aqueous solution. So that means soluble, soluble, soluble. So it's a colorless solution. And then you're going to get white precipitate because the chloride and the silver will combine together and you will get silver chloride. So what I can tell you is this precipitate refers to silver chloride. If I just write that properly, that is your AgCl, silver chloride. That is your white precipitate. And then I have AgBr. This is your cream precipitate, the test for bromide. And last but not least, we also have silver iodide, which is the yellow color precipitate. So AgI is the yellow color silver iodide. Now this comes back to year 9. Year 9 chemistry contents, year 9 chemical formula, and you also learn about naming as well. So the silver ions is Ag+. If I just show you Cl-, for instance, then there is 1 and 1. So that means there's how many of that ions you have after you exchange the valency. Hence the overall formula is just 1 of the Ag+ and 1 of the Cl-. And because you know that the elements in the same group where you have Cl-, Br-, I-, you have chloride, bromide, and you have iodide. So all of them are -1, -1, -1 because all of them belong to group 7 with 7 outer shell electrons. You all form ions of -1 charge, and therefore your valence is just 1 there. And your formulation of the precipitate silver halide, the test for halide anion, chloride, bromide, iodide, you get a white precipitate. Make sure you know how to spell precipitate. So precipitate is the noun. Precipitate means it's a solid. You get a white solid which is insoluble. There's silver chloride. You see this, you don't see silver chloride, you see a white precipitate. You see a cream precipitate, that is silver bromide. You do not see silver bromide, you see cream precipitate. You see a yellow precipitate if iodide is present. This is the test for these ions. If you see this, it means these ions are present, but only if you added nitric acid first of all, and then you add silver nitrate. These are very important that you have added these two together, and they will be easily worth 2 marks there. In terms of the test for gases, chlorine as a molecule as an element is a diatomic molecule. Bleaches. What does bleaches mean? It means that the litmus paper, which is colored, whether it's blue or red litmus paper, it will go white. So it doesn't matter what litmus paper you use, both the red and the blue, both of them will go white. So it becomes white. It is what you use as a bleaching agent. Whatever colored will become white in color. Bleaches are damp. Damp meaning to say a bit wet, a bit moist, a bit dampened, means you dampen it with a little bit of moisture or just a little bit of water. Doesn't matter red or blue litmus paper, both of them will get bleach, B-L-E-S-C-H. That means it become white in color. So I'll just break this lecture tutorial for a little bit, and I'll show you experimental tutorial videos, experimental video showing you the bleaching of these litmus paper where chlorine is present. I'll be back shortly. So here we're going to have this test for halide. So we put in a bit of solid. We put in some distilled water because distilled water does not contain any other impurities. So it's the best solvent to use in order to test for any ions. First of all, we must acidify with some dilute nitric acid, that is HNO3. So the first thing we do is we acidify, or we add some HNO3, we add some aqueous, or we add dilute nitric acid. After we add the dilute nitric acid, we add this silver nitrate solution, which is colorless. And what do we observe? We could see a white precipitate forming. So we acidify with nitric acid first, and then we added in the aqueous silver nitrate, which was colorless, and we get a white precipitate. Silver chloride precipitate is white in color. And now we're going to test for the second one, which is the test for bromide ions, Br minus ions. Acidify with some nitric acid, which is aqueous nitric acid. Then add in the colorless silver nitrate solution. We get a cream precipitate, a cream color precipitate. So not a white, but a cream precipitate of silver bromide. We do the same thing for our test with iodide. And we get the third precipitate, which is silver iodide precipitate, and that is yellow in color. And that was after we acidify with nitric acid, and then we add in the aqueous silver nitrate, we get a yellow precipitate. So overall, white color silver chloride, AgCl, cream color, AgBr, as well as yellow color, AgI, silver iodide. All of the halide were tested with addition of dilute nitric acid, and then you add in the aqueous silver nitrate, you get a different color precipitate, white precipitate, silver chloride, cream precipitate, silver bromide, yellow precipitate, silver iodide. So test for chloride, bromide, iodide ion respectively. Not. So this is concentrated HCl. It's not very good to breathe in it at all. I think that should be enough, I guess. Okay, let me just add a bit more. So disgusting kind of mixture, concentrated hydrochloric acid, concentrated HCl, and this manganese 4 oxide. So I'm just going to moisten my blue litmus paper a little bit. We know that Cl2 is an acidic gas. So as I put my blue litmus paper on top, you can see my blue litmus paper. Hopefully you can see my blue litmus paper has turned red. Not sure if you can see it. My blue litmus paper that was moistened, that was dampened with water, the blue litmus paper has turned red. I'm just going to leave it there on top for a bit longer. So the blue litmus turns red because Cl2 is an acidic gas, but then the proper test for chlorine gas is it will bleach the blue litmus paper as well. So not only the blue will turn red, eventually it will go bleach, it will go white in color. If I just leave it there a bit longer. I'm going to test it similarly with a red litmus paper. The red litmus paper is used to test for alkaline gas such as NH3, but here we have acidic gas, so technically speaking I will not get any color changes with the red litmus paper. So that was the blue litmus paper turning red. So the red litmus paper should not turn blue at all. In fact, there is no color change even up until now. I am still waiting for this. So there is gas coming off, but there is no color change whatsoever from the red litmus paper because, well, it is not acidic. But if I leave both of them there, I'm just going to add in some more hydrochloric acid so that I can make more chlorine gas. So I'm just going to add in more concentrated hydrochloric acid. So I just want to make sure that my blue litmus just now, it turned red. Let me show it to you again. So as I'm producing chlorine gas, so my blue litmus should turn red. As you can see, my blue litmus has turned red because, you know, the chlorine gas is generated from this reaction of manganese 4 oxide and concentrated acid. I should leave this blue litmus that has already turned red here a bit longer, and it should get bleached. It should turn white in the end. As to whether I use red litmus or blue litmus, it will get bleached according to the proper test for gases. As long as you have Cl2 gas, diatomic gas, being produced, it should turn white because it gets bleached in the end. While waiting for that to get bleached, I am preparing this thing for the test for the next gas. This is a purple colored solution. It is KMnO4. KMnO4 is an oxidizing agent. Hang on, I think this thing is already changed. You could see it turning a bit white now. So it was blue to red because it was acidic, but now it's gone a bit white. It has gone bleached. So the litmus paper has been bleached because chlorine gas is present. Cl2 gas is present. Cl2 gas turns blue litmus paper to bleach, B-L-E-S-C-H-E-D. I could have tested it with red litmus. It will give me the same result, but then it will not turn to blue. In fact, it will just get bleached after some time. Hello, I'm back again. So that was it. That was just a short experimental tutorial video that shows you that chlorine bleaches a damp litmus paper. Unfortunately, I don't have a recorded tutorials, but I will show you the test for the Halide Ions where I get the silver chloride, silver bromide, and silver iodide eventually. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. I'll see you in the next tutorial video where we'll finish off this Group 7 Halogen Chemistry.